During the construction of large bridges built over water, the biggest challenge for engineers is the water itself. Once again, dear viewers, welcome. We don't even realize how many bridges we cross every day, yet most of us never pay attention to the masterpieces of construction hidden within them. Bridge construction is far more difficult than building construction, because a building bears a static load, while the load on a bridge is never constant. A bridge must withstand millions of tons of heavy load at all times, and that too, a moving load, constantly shifting from one place to another. As the population grows, the importance of bridges and flyovers also increases. And this importance multiplies even more when the bridge is built not on land but over water. Yes, while workers face difficult challenges when constructing on land, those challenges become 10 times harder when construction happens over water. In water-based bridge construction, not just 11 inches, even 11 millimeters are calculated in advance, because if even a single millimeter of error occurs, it can cause losses of billions of rupees and thousands of lives in an instant. Whether it is a house, a building, or a bridge, one thing is always common: the foundation. Just as no structure can exist without a foundation, a bridge cannot be constructed without one either. This raises a question: when a bridge is built over deep seas and rivers, its foundation lies under the water. But how exactly is this foundation made beneath the waves and thousands of liters of water? And how can underwater foundations be so strong that they hold the entire bridge steady against the pressure of water and waves? That's exactly what you'll learn in today's video. The very first task for an engineer in underwater construction is to examine the depth of the water and collect information about the ground beneath it. How deep is the water? Is the riverbed rocky or sandy? To find out, professional scuba divers go all the way down to the bottom, and for weeks they only work on gathering information. If the water is shallow, the foundation is easier to build. But if it's deep, workers' lives are at risk, and both the cost and labor increase tenfold. After information collection, the next phase is the most important: how to remove water from the construction site. Yes, no matter how deep the water is, it must be removed from the location where the foundation will be built. But how can such deep water be removed? Engineers use three main methods. Method 1. Cofferdam, the oldest technique. Soil is piled up all around the site until it rises above the water level. Then, the enclosed water is pumped out, leaving a dry work area. Construction can then proceed normally. But it's not that simple. Often, the soil wall weakens and collapses under water pressure, flooding the site and endangering workers' lives. To solve this, engineers also use steel sheet piles instead of soil. Large iron sheets are driven into the riverbed, forming a strong barrier. Once construction is complete, the sheets are removed. Method 2. Caissons. Here, the foundation is built on land first and then transported by ship to the exact spot in the water where it is needed. The caisson is shaped like a large box, closed at the bottom, open at the top. If simply placed on water, it would float, just like a glass turned upside down in water. To prevent floating, engineers first dump large stones into the waterbed to create a stable base. Then, the caisson is carefully placed on top using cranes. Finally, concrete is poured inside it, making it heavier and much stronger. Method 3. Battered piles. When the water is too deep for caissons, engineers use long steel pipes called piles. These giant piles, weighing thousands of tons, are transported to the construction site. But how are they driven deep into the seabed? Special giant hammers are brought in, which repeatedly pound the piles, forcing them deep into the riverbed. Once secured, not even massive waves or sea storms can shift them by a millimeter. This creates an extremely strong and stable underwater foundation upon which the bridge can then be built. Of course, all this is far easier said than done. The entire process takes years of hard work and often costs human lives. Now, let's look at the 10 longest bridges in the world, built on both land and water. Number 10. Richmond San Rafael Bridge, USA, completed in 1978, 36 km long. Number 9. Jiaozhou Bay Bridge, China, completed in 2017, 37 km long. Construction took 13 years. Number 8. Lake Pontchartrain Causeway, USA, completed in 1966, 38 km long. According to Guinness World Records, it's the longest bridge over water. Number 7. Beijing Grand Bridge, China, completed in 2010, 48 km long. Number 6. Bang Na Expressway, Thailand, 55 km long. Number 5. Vinan Vehe Grand Bridge, China, completed in 2008, 79 km long. Number 4. Chengde Grand Bridge, China, 106 km long. Number 3. Tianjin Grand Bridge, China, completed in just 4 years, 113 km long. Number 2. Changhua Kaoshi Viaduct, Taiwan, 157 km long. Number 1. Danyang Kunshan Grand Bridge, China, completed in only 5 years, 165 km long. 10. Zero workers labored simultaneously, and the total cost was 8.5 billion. We hope you won't keep this knowledge to yourself. If you like this video, give it a big thumbs up and share it with your friends. Thank you so much for your loving comments. See you in the next amazing video.